In the last video, we talked about measures of position. So take a look at these two questions and all of their parts, pause the video, and then unpause the video to get the results and make sure that you are remembering those concepts clearly. Okay, for number 1, we take the data value 65.8, subtract off the mean of 51.2, and divide by the standard deviation of 2.3. We get a z-score of 6.35. This is 6 standard deviations above the mean. This Siberian Husky needs to go on a diet. Okay, number 2, part A, quartile 1, that's percentile 25. And I said that that corresponds to a score of about 65. D8, that is percentile 80. I said that corresponds to a score of about 90. P40, this corresponds to a score of approximately 78. And the median, I said, was approximately 85. Remember the median, you have to go across from P50, or the 50th percentile. All right, we reverse the process. So a score of 90 corresponds to, I said, approximately Q3. A decile, what decile is a score of 60? I said that was decile 1. And then a score of 95, I said that was a percentile of 90. Again, these are estimates, guys, so if you're in the general ballpark, you're fine. Today's lesson is going to be talking about box plots and outliers. Okay, so first of all, just a reminder that a box plot uses the 5-number summary in order to make a box plot. Those 5 numbers are the minimum, quartile 1, the median, quartile 3, and the maximum. I put a picture to the right of a box and whisker plot, or a box plot. So we can see that the box contains quartile 1, the median, and quartile 3. And then the whiskers extend out to the min and the max. That interquartile range that we talked about in measures of variability section is that difference between the quartiles. Quartile 3 minus quartile 1 would give us that IQR. All right, we're going to go ahead and construct a box plot for the data that's listed there. That data is already put in numerical order, which is key to finding the median and therefore finding the quartiles as well. So it is a sample of 10 boxes, so there's not going to be just one number in the exact center. So if we look, it looks like the 30 and the 34 are the 2 values in the center of the distribution. And when we have 2 in the middle, we add them up and divide by 2, and this gives us our median of 32. If you remember, the median cuts the data in half, so we find the median of each half to find the quartiles. So the number in the exact center of the lower half, there are 5 numbers there, so in the exact center is 29. So that is Q1. And in the exact center of the upper half is the 35. So that is Q3. The min and the max are 25 and 38 for this data set. So in order to make that box plot, I am going to construct a number line. Mine is going to range from 25 to 40. And my scale, I'm just going to count by 5s. So 30, 35. Okay, so quartile 1 forms the left side of my box. Quartile 1 is at 29. The median is 32. And then quartile 3 is 35. So I'm going to connect those lines to make the box. And then I'm going to extend out to the min and extend out to the max to form the whiskers. We can also do this on our graphing calculator. So I'm going to go ahead and go through that process now. We would go to Stat and enter on Edit. And we're going to enter these numbers into list 1. Okay, I finished entering those numbers into list 1. We're going to hit second y equals. And right now my plot number 1 says off. I'm going to enter on plot 1 so I can change those settings. I'm going to highlight on. And also I'm going to pick the type of graph that looks like the box and whisker plot. Notice there's actually 2 that have the general shape of a box plot. For this particular example, we were just asked to construct a box plot, so we're going to choose the one with no dots. We'll be talking about this one with the dots in just a moment. Okay, if I highlight that box and whisker plot, and I did use list 1, I want to keep the frequency at 1. Now, if I hit graph, I may not see any points. This is because the graphing calculator is not zoomed in on the values that I have. The standard viewing window is from -10 to 10. That is not covering. My data is from 25 to 38. So what you can do is you can hit zoom and then pick the one that says zoom stat, which is number 9. This is going to zoom in on the numbers that you have stored in the stat edit screen. So basically in your list 1. And there's my box plot, which looks very similar to the one that we constructed by hand. You can press trace and then toggle left and right to see the values of the minimum, Q1, the median, Q3, and the maximum. Another type of box plot is called a modified box plot. And this is when the outliers appear as separate data points outside of the whiskers. So if we had a large outlier, actually this example has 4 large outliers, we see the outliers as separate dots, and then the maximum line stops at the largest number that's not considered an outlier. The other measures are unaffected. We could also have a low outlier. There would be separate points below the minimum, and then the new minimum would become the smallest value, again, not considered an outlier. We need to talk about how we determine if a data point is technically an outlier. So there are 4 steps in this process. First, we have to find the IQR, the interquartile range. Remember, we find that by subtracting Q1 from Q3. We then multiply the IQR by 1.5. We take that value and subtract it from Q1 and add it to Q3. This will give us a range of data values. Anything outside of that range is then considered an outlier. Let's take a look at an example where we determine if a data set has outliers using this 4-step process. So here are grades on the Chapter 4 quiz. We have the grades listed there, but I've also listed them in order. Okay, let's go ahead and follow those 4 steps by first finding the interquartile range. Okay, so I'm going to first find the median. Okay, it looks like the median is 83. This splits the data into 2 halves, a lower half and an upper half. It looks like the middle of the lower half is 73, so that's Q1. And the upper half is 92, so that's Q3. If I find the IQR, I would subtract Q3 minus Q1. So I get an interquartile range of 19. Okay, the next step is that we're going to multiply that interquartile range by 1.5. So I'm going to go ahead and do that over here. 19 times 1.5 gives me 28.5. So I'm going to take Q1 and subtract 28.5 from it. And I'm going to take Q3 and add 28.5 to it. Okay, so Q1 was 73. And again, we're subtracting the 28.5. So that gives me 44.5. And if I take Q3, which was 92, and then add the 28.5 to it, I get 120.5. Now I'm going to scan the data point and see if there's anything outside of that range. So is there anything lower than 44.5? Yes. 10 is outside of that range, so the 10 would be considered an outlier. Let's just double check on the upper half, or the upper numbers. 120.5, is there anything outside of that number? No, 100 is the maximum, and it is in the range of 44.5 to 120.5. So therefore, there are no large outliers, just the small outlier of 10. We are going to use this to go ahead and construct a modified box plot. So I'm going to try to squeeze it down here at the bottom. I'm going to come up with my number line, which ranges from 10 to 100. Okay, so there's my scale. I'm counting by tens. And 10 is an outlier, so it's going to be a separate dot. The new min is going to be the next smallest number, which is 50. My Q1 is 73. My median is 83. My Q3 is 92. I connect those three to make my box. And I'm going to switch this should be just a point. And my max is 100. So if I connect the new min and the max, and then again leave the outlier as the separate point. That would be what a modified box plot looks like. I can also do this on the graphing calculator. So let's go ahead and enter those data points by pressing Stat and Enter. Highlight L1 and clear Enter to delete the list that was already there, and go ahead and re-enter those data values. Okay, I finished entering those in list 1. I did the unordered version. You could enter the ordered data set. You can also order the data set in the calculator. So if you press Stat, down arrow to sort ascending, hit enter, and then you do have to tell the calculator what list the data values are in. So we use list 1, so we're going to hit second 1. The calculator is going to say done, and now when we go back into Stat Edit, we see the numbers are in order from least to greatest. Just so you know, you do not need to order the data in order to make the modified box plot. We're going to go to second y equals. Again, I'm still going to use plot 1, but I need to change the type. I want to choose the modified box plot, which is the box plot with the 2 dots to the right-hand side. It doesn't matter if they're low outliers or high outliers. It's going to show them as separate points. Again, we use list 1 and we want to keep the frequency 1. I'm going to go ahead and hit that zoom 9 for zoom statistics, and we can see the modified box plot has the low outlier as a separate dot. If I hit trace, again, I can toggle between the values used to make that modified box plot. In the last lesson, we talked about measures of position. Since box plots are using quartiles, we could very easily answer questions based on those measures of position using the box plots as well. Okay, so we're going to take a look at this modified box plot on the right and answer those 4 questions. Number 1, what % of employees make more than 87,000? So if we find 87,000, that looks like it's corresponding to approximately the median. So the median, remember, is percentile 50. So 50% of employees make less than 87,000 and 50% of employees make more than 87,000. So this first answer is 50%. What % make less than 77,000? If we find 77,000, it looks like 77,000 is corresponding to the first quartile. So quartile 1 corresponds to percentile 25. So 25% of people would make less than 77,000. The next question is asking us what salary represents the outlier. We see the outlier is the separate dot. That corresponds to a salary of 145. That is in thousand, so 145,000. And the last question, how much does the lowest 25% of employees make? So the lowest 25% would correspond to the first quartile. So that would be approximately 77,000 or less. Back-to-back or parallel box plots can be used to compare data. This is asking us to compare female and male ages of Oscar-winning actors from 1975 to 2004. They want us to compare and contrast using a measure of center, a measure of variability, shape, and outliers. So taking a look at measures of center, an easy measure of center to use when comparing box plots is the median. It's going to be the line, remember, in the middle of the box plot. So we see females is here versus males are here. So it does seem like the males are centered at a higher value than the females. So males earn Oscars on average later in life than females. Measure of variability, an easy measure of variability is to use the IQR. It's the difference between the quartiles. So it's basically the width of the box. So we see that females are less variable because their box is smaller than the males. The IQR of females looks like about maybe 42 minus 32, so about 10, versus the males interquartile range looks like about 51 minus maybe 37. So that would be an interquartile range of about 14. So males are more variable than females. Shape, if we take a look, it looks like females are approximately symmetric, and males, it looks like, is more right skewed. Again, I'm kind of looking at the distance between the median and the min and the median and the max. This one looks approximately the same distance from each side, whereas the males, the right side is longer. And outliers, we have the females have more large outliers than the males. So overall, it looks like females win Oscars earlier in life, whereas males earn Oscars later in life. Okay, this last slide is a you try. So what I'd like you to do is take a look at number 1, determine if there's any outliers, then construct a modified box plot of that data and answer the 3 questions that follow. Pause the video here and then unpause to get the answers. Okay, so following the 4-step process, I first found the IQR to be 5. Quartile 3 was 7 and quartile 1 was 2. So if we take 7 minus the 2, we get the interquartile range of 5. I multiplied that by 1.5 and got 7.5. I subtracted that from quartile 1 and I added it to quartile 3. So our range of values is negative 5.5 to 14.5. The only data value that is outside of that range, and just barely, is the 15. So the 15 is considered an outlier. I used the modified box plot on the calculator to construct this graph, and then I answered the questions based off of that. So what percent of data is more than 4? 4 was the median, so that means 50% on the left, 50% on the right. What percent of data is less than 2? 2 is quartile 1, so 25% of data is less than that. And then what percent of data is less than 7? 7 is quartile 3. That corresponds to the 75th percentile, so 75% of data. Okay, this concludes the lesson on box plots and outliers.